Good morning, everyone. My name is Richard Wade, and I travel around doing shows about science for young people.
Welcome to the library. Let's go see a show.
Bubbles, one of nature's most beautiful structures. So light, so pretty, so delicate, so irresistible. Why we have to kill bubbles, I don't know. So fragile. There you go, Chris. And so very, very powerful. Yes, powerful. You'll never have the same, you'll have a new respect for bubbles. You'll never look at them quite the same. Now you may be curious, this show's about volcanoes, and the first thing I do is blow bubbles. Well, by the end of the show, you'll understand that the power behind volcanoes is bubble power. By the end of the show, you'll understand the reason a volcano can erupt and throw thousands of tons of rock high in the sky, can throw dust all the way around the world. The reason a volcano can explode with the force of thousands of nuclear bombs is exactly the same reason that this happens. Yes, exactly the same reason, because inside this bottle is this stuff called soda water. Same kind of water you'll find in a Coke or a Pepsi. It just doesn't have the sugar or the fruit juice. It's just water and the stuff that makes sodas fizzy. And that's a gas. Air is a mixture of many gases, and the gas that we breathe out is a gas called carbon dioxide. And carbon dioxide is a gas that can be squeezed like a spring really tightly. So inside this bottle are millions and millions of tiny little bubbles of carbon dioxide. Squeezed in there so small you can't see them. They're in there, but you can't see them. They're in there so tiny. And they're all waiting like little springs, waiting for a chance to get bigger. And when I warm the water up by shaking it, that warms up the bubbles. And they push, trying to get bigger, but there's no room for them to get bigger unless I give them a little room. And then they all get bigger all at once, and they push the water around them out. And that is exactly why a volcano erupts. But water doesn't come out of volcanoes usually. What comes out of a volcano? That's right. But lava is rock. It's heavy. It doesn't come up by itself. It has to be pushed up by something. And inside lava is a lot of carbon dioxide bubbles. Already hot, waiting like springs, waiting for a chance to get bigger. As long as there's rock on top of it, it can't get bigger. Now, I mentioned that lava is rock, right? So you've seen it on a TV show. You saw a volcano on a TV show, and it was a liquid, wasn't it? That's because some things, when they get hot, they don't burn, they melt. Whether it's rock or crayon. If it gets hot enough, it will turn from a hard, solid thing to a liquid. Now, I'm going to be doing a couple of things up here with fire. But that does not mean that it's okay to go home and do this, and you've all heard that phrase, kids, don't try this at home. That doesn't mean go to your best friend's home and try it over there instead. No. Don't play with fire. But whether it's rock or a crayon, it will turn from a solid to a liquid. And it'll drip and flow as a liquid. And then, when it cools, it gets hard again. So lava is rock that is so hot, it flows. But on that TV show, you saw that volcano and the lava coming out, and it wasn't black, was it? What color was it? Red, that's right. Because some things, when they get hot, they glow. Whether it's rock or steel, as in this ordinary paper clip, it gets to be 1,500 degrees, the heat will become visible as light, and it'll glow like a little light bulb. And remember, Don't play with fire. Hotter and hotter and hotter until it starts glowing like a little orange light bulb. And then when it cools, it gets dark again. So lava is rock that is so hot it flows and it glows. Now let's look at where it comes from. It comes from deep in the earth. Here's a model of our Earth, a globe 1 foot across. The real world is 46 million feet across through the middle, so it's a 1/46 millionth scale model of the Earth. What's all this blue stuff? Water, so much water covering the Earth, but it's much less water than we would really like to think. Water is what makes life possible on the Earth, but it's extremely thin. If the world was actually only 1 foot across, all the water on the Earth everywhere would be 1 tablespoon of water. Only 1. So it's thinner than the thinnest coat of paint because I used a lot more than just 1 tablespoon of blue paint when I painted this. It's also, what's all this green and brown stuff? Land. That also is much thinner than we would like to think. The crust of the Earth on which we live our lives is thinner to the Earth than an eggshell is to an egg. The thickest part of the crust of the Earth, if the world was 1 foot across, would be the thickness of about 1 piece of paper. Just 40 to 80 miles beneath your feet right now, most of the world is made out of this. Most of the world is made out of rock, so hot it glows and flows, and we have 2 names for it. When it comes out of a volcano, we call it lava, and when it's deep in the earth and no one has seen it, we call it magma. Excellent, that's right. So technically, no one's ever seen magma because we rename it when it comes out of a volcano. We call it lava, but it's the same stuff. Rock, so hot it glows and flows. It's just a thin, thin shell of rock on which we live our lives, protecting us from this gigantic ocean of molten rock. And if you go a few thousand miles deeper, it gets much hotter and much heavier. It goes from 2,000 degrees right on the outside to 10 to 15,000 degrees in this outer core. And most of the metals have sunk into the center of the Earth. The heaviest things have sunk into the middle of the Earth slowly, and the lightest things have floated to the top. The rocks around us that we see on the surface seem heavy to us, but they're actually the lightest materials that make up the Earth. This outer core is made out of aluminum, copper, iron, zinc, and almost all the metals, just a few trace metals on the outside for us to use. And if you finally go a full 4,000 miles to the center of the Earth, there's a white-hot core of iron and nickel, hotter than the surface of the sun. It is so hot it ought to be a gas. But it's squeezed by the billions of tons of rock on top of it back into a solid again. So we have this thin shell of rock on which we live our lives, this huge ocean of molten rock and metal, and then kind of a peach pit in the middle, a hard core. And the only reason we know what it's like inside the Earth is volcanoes bring us samples, and we listen to the sound of earthquakes. Small earthquakes go around the world all the time. We don't feel them, but they make a sound that goes through the gooey parts and the hard parts slightly differently. And so by listening very carefully with instruments, we get a picture of what the inside of the Earth is like. And so a crack will form in the surface of the Earth on which we live our lives, and that carbon dioxide bubbles will push some of the lava out, and it'll flow out onto the ground. And just like the crayon, it'll cool and harden. And if there's more to come out, it'll pile up on top of itself into a hill. And if there's more to come out, it'll pile up until it's a mountain. Thousands of feet tall. Some of the biggest mountains in the world are volcanoes, and they build themselves with bubbles. Now the stuff, this lava rock, when it cools, the bubbles leave holes. So very typically, lava rock is full of holes, and sometimes it has so much holes in it, it's more hole than rock, making some of it so light it'll actually float in water. Rock that floats. It's called pumice. It's really gritty, and we grind it up and make cleansers with it. But this stuff, this lava rock, if it sits out in the weather for thousands of years, it starts to crumble and become soil around the volcano. good rich soil. There's so many minerals in lava that it becomes good soil, good for plants to grow. And so very often around volcanoes, you'll find lots of forests and jungles growing. And wherever you have lots of plants growing, you'll always have lots of animals living. Well, life around volcanoes is rich and diverse, all because the lava becomes good soil. And from the earliest of times, people have lived near volcanoes because that's where the food was. That's where the plants were to gather and the animals were to hunt. And to gather plants and hunt animals, people needed tools and weapons. And long ago, before we knew how to make tools and weapons out of metal as we do today, we had to make them out of stone. And it was called the Stone Age. And it's very hard to make a tool or a weapon with a sharp edge or a sharp point if all you have to use is a piece of stone. Unless it's a special kind of stone that comes out of a volcano called obsidian. Obsidian is glass. It is exactly the same stuff as in a window, silica. But it's been inside a volcano, so it has other minerals in it that make it black. Black volcanic glass. And glass, as you know, if you chip it, it makes a super sharp edge. Sharper than a razor, sharper than a scalpel. The sharpest edge we can make is that of obsidian. And so with great skill, long ago, people would chip obsidian into very useful things. Arrowheads, spearheads, knives, daggers, axes, even razors. A valuable thing back then. So people lived near volcanoes because that's where the food was and that's where the tools were. And then when we learned how to chop down the trees and clear away the land, that good soil that was good for the jungle was also good for farming. Where the soil is good, the farming is good. Where the farming is good, the living is good. And so farms would grow and grow and become villages. And the villages would attract more people and they would grow into towns. And the towns would bring more people and they would grow into cities. And some of those cities would become super mega cities until the situation we have today, where hundreds of millions of people live right at the base of very dangerous volcanoes. The two biggest cities in the world, Tokyo and Mexico City, are right at the base of sleeping, very dangerous volcanoes. And why are they dangerous? What comes out? Lava. Eventually there's enough carbon dioxide bubbles to push some of the lava out. And it'll flow down the side of the mountain, making it a little bigger on that side. But it's not thin and runny and fast like water. It's thick and gooey and it oozes along like peanut butter slowly. Usually no faster than a person walks, sometimes as fast as a person runs. But it always goes downhill. So people have enough time to just walk uphill and get out of its way and it goes past them. It'll make a mess wherever it goes because it's rock, even though it's a liquid, so it'll crush whatever it goes over. And it's at least 2,000 degrees, so if it just comes close to a tree or a house of wood, the heat coming off will make that tree or that house burst into flame. But people have enough time to get out of its way, so it's very, very rare that anyone has ever been hurt directly by lava. However, there's another stuff that comes out of volcanoes sometimes that is very dangerous and has harmed many people. And that is this stuff called volcanic ash. Volcanic ash is not like the ash that you'll find in a barbecue or a fireplace. Volcanic ash is rock that's been blasted out of a volcano so violently. It's been turned to the finest dust you can imagine. A dust finer than chalk, finer than flour. A dust so fine that it floats in the air, but it comes out by the billions of tons all at once in a great big poof. And it'll spread out across the sky and cool just enough to start falling like snow. But it's not cool and light like snow. It's hot and it's heavy and it chokes and it burns. And people run inside their houses and it builds up on the rooftops, heavy as rock, and it crushes the roofs in. And the worst thing it does is it covers up the land where people are growing their food crops.